Here we do another example of writing systems of loop equations. We want the current that is going through this underlined resistor here. The first thing we do is we draw in some currents and we just arbitrarily pick a direction that we think they're traveling in. And if we guess correctly, great. If we don't, it just means the current value that we get will come out negative and it points the other way. No big deal. Well, this is a 12-volt battery, so I'm going to assume that there's an I1 current that's going around in that direction. And then there are all kinds of ways you can do this. I'll show you a slightly different way here. I1, 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 and then right here, let's assume that that I1 splits and that an I2 goes that way. Well, if I1 goes into that junction and I2 splits off, then what is going this way is I1 take away I2 and check to make sure that that's consistent. Watch this. I2, 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 I2 up to right there. And then right here is I1 minus I2. So those two are going to feed together right there. You've got an I2, you got a minus I2, so you get an I1. Dip, 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 right through there. Now we need to write some loop equations. So we need to pick some point. I'm going to go right there. And we need two loop equations because we have two unknowns. I'm going to choose the leftmost loop, and I'm going to choose the dot, and I'm going to go clockwise around there. Here we go. The first thing I run into is this 12-volt battery, and then because we're traveling in the same direction as our assumed current, we got to go minus IR, and we're going just around the left loop here, so we're traveling in the same direction as our assumed current, so we're going to go minus IR. And now we're back to our dot, 0. Let's simplify this. I'm seeing a 12 here, and then a total of negative 20 I1, and then positive 8 I2, and that equals 0. So that's one loop equation. Now let's make another loop equation, and this time what I'll do is I'll start at the dot again. How about that? And I'll go this way, and I'm going to go around the outside. I'm going to go around the whole loop this time. This portion is not going to be a part of it. I'm starting and ending at the dot again, but this time I'm going to go all the way around the perimeter. Let's see what that gives us. 12 volts is the first thing we run into, minus 12 I1. Now we're going around the perimeter. Now, right at that point, then you see it changes to I2, but there's no resistor there, so we don't have to do anything with that yet. But we're going through this battery opposite the way it's pointed, so I'm going to say minus 8. And now here comes I2 going in that direction, so we're going to go minus 4I2, and then we're back to the dot. What does this simplify to? 12 minus 8 is 4, and then the I1 is going to be minus 12, and the I2 is going to be minus 4. Whoops, I forgot the I2 in there. I2 equals 0. Sorry about that. Okay, let's write our system of equations. What's the deal with the system of equations? We have to have the constants on the right and all the variable stuff on the left. I'm going to move this 12 over to that side. So there's my I1 number, negative 20. There's my I2 number, 8. And then I've moved the 12 to the other side, so minus 12. This side here, we'll do the same thing. The I1 is going to be minus 12. The I2 is going to be minus 4. And then the constant will be minus 4 because we have to put the constants on the right like that. And if we wanted to multiply this whole equation on the bottom by negative 1 so that they all became positive, that's fine. No problem. But just to show you that it works, I'm going to just leave it like that. All right, so we go into our graphing calculator now, and we go to matrix. So you hit your second matrix. We're going to edit. This is, again, a 2 by 3 matrix. So we're going to enter the numbers just like we're reading a book. Negative 20, enter. 8, enter. Negative 12, enter. Another negative 12, enter. Negative 4, enter. Negative -4, enter. So there's our matrix A right there. Now we're going to quit. We're going to go back into matrix. We're going to go to math. We're not going to hit enter now, but we got to toggle down until we get to our REF right there. Now we hit enter, and we need to put in the matrix right there that we want it to do this operation on. So we hit second matrix, and it's automatically toggled over to, hey, matrix A, is that what you want? And you hit enter. So now you've put matrix A in there, and now you hit enter again to tell it to do its work. There we go. All right, let me write these down. Sneak that over. I got I1 to be 0.455 roughly. I1 is 0.455 amps, and I2 is negative 0.364. Negative 0.364 amps. What does that mean? Well, it means that we guessed correctly which way I1 went. 0.455 amps, it does in fact go this way. But this I2 that I've drawn here, it doesn't actually flow in that direction. The current flows opposite that. No big deal. Now, all along we've wanted to find what the current is in this 8 ohm resistor. The current that's flowing there is I1 minus I2, I1 minus a negative I2. So you have to take that into account. So in effect, we are ending up adding these. I1 minus I2 is going to be 0.455 amps minus negative 0.364 amps. Amps is in there. And you know what that gives us? Look at that. We were told from the beginning that our answer would be 0.81 amps, and it would be pointing down and to the left. And look at our picture. Down and to the left. And if you put those together, those negatives cancel out. You end up with a positive right there, 0.81 amps. All right, that's pretty neat.